Okay, we're going to be simplifying radicals. I think this is going to be a review of what we've already done.
Yeah.
We've already done cube roots and fourth roots and so forth, and now we're going to be pulling some of them out if we have perfect square roots inside. So I'll read this top part. A radicand might not be a perfect square, but if any of the factors are perfect squares, the radical can be reduced to the simpler form using the product property of radicals in reverse. And so reversing the product property takes the factors of the radicand and puts them under separate radical signs. So here's our property, and I think we did it backwards before. We said that if we had a radical of some index, and if we multiplied it by same index to another one, we can just multiply the a and the b. Well, we're going to go backwards with that and say that if we had this one, we're going to actually start off with the original. If we have two things that we can find its factors, we can separate into two pieces. And if one of those pieces happens to be a perfect root, we can pull it out. Okay. So for example, if we have the square root of 300, we can do this two different ways. I'm going to actually do it two different ways. I'm going to do it the way they show us, but I'm going to also show it the way that we've done it before. So can we think of something that's a perfect square root that multiplies to make 300? 3 isn't a perfect square root. Like 4 is, and 49, and 25.
Oh, okay, so 2 would not go into
2 does go into it, but 2 is not a perfect square root. This is the harder one, because you have to think of it. 10? And so what 10 isn't a perfect square root, but 100 is. Yeah. And 100 times 3. So 100 is a perfect square root, which is
right, because it would be 10.
But the 3 is not, so it stays under. Okay. But if you can't think of a perfect square root, this is another method. We take that 300 and we do this.
Okay.
And we say this is
103.
Yeah, since we just did that. Well, let's pretend we didn't know that. Let's say that we knew that it was 5. We knew 5 went in it, and we knew it went in 60 times. Okay? And 60 is 6 and 10, right?
Mm-hmm. And 10 and 5. And
6 is
2 and 3.
2 and 3 and 2 and 5, okay? So we have, under the square root, 5 and a 5, a 2 and a 2, and a 3, okay? This is a perfect square root, because 5 times 5 is 25. Mm-hmm. And that's a square root.
4.
Okay, it's a 4. So the doubles are perfect square roots. And the doubles, we know they're perfect square roots, come out as a single 5. And that double comes out as a single 2, and left over is a 3. What is that, 5 times 2?
10.
10. We got the same answer. It did take us a little longer. But if you can't come up with, if you can't figure out what's that perfect square root, this might be a procedure to use. Okay? Let's try the 16 with the cube root. It works the same with cubes and squares. If I have the cube root of 16, I still do my factor tree. That's 4 and 4, 2 and 2, and 2 and 2, okay? The last one we were doing, we did square root, so the doubles came out. Mm-hmm. When we're doing cube roots, the triples come out. I gotta make sure that's long.
2 out front.
Uh-huh.
And then a 2 and a 4 and a 4. And
this come out as a single. Mm-hmm. And so what's left?
A 2.
A 2.
Oh, right, not a 4.
Right, because the 4 became split out. Right?
Right.
So this is 2. Cube root of 2.
Okay.
Okay. So now we're going to do a couple of your homework problems. Just maybe 2 of them. Pick one of them, the ones you think is the hardest over there.
32 and 75.
Okay, so the square root of 75. Which one did you like the best? Did you like where you had to, this one where we had to pick, or this one where we did the factor tree?
Well, for this one, the factor tree, because I don't know what the perfect root of 75.
And after you get enough practice, for me, it took quite a while. I'd be able to see it because I know what the answer is right now, but you don't have that practice. Mm-hmm. Okay, so we're going to do 75. What multiplies to be 75?
5.
And?
I have no idea.
1 and 5 and 2 5,
Oh, 15.
15. Okay, so I'm going to undo all that. Oops. Okay, 15,
5 and 3.
5 and 3. Okay, so what do I write underneath this radical?
5, 5, and 3. And then you would have 5 on the outside and then just 5 and 3 on the inside.
Good. Okay, and then you wanted to do 32? Is that what you chose? Okay. And it's the square root. They don't look like they're giving you any cubes or anything. Okay.
And for this one, 4 and 8 going into it.
Okay.
2 and 2. 2 and 4, which breaks down to 2.
Wow, how many 2's do we have there?
5.
5. 1, 2, 3, 4, 5. Now you could have written it 2 to the 5th power, but I like to see the doubles when I'm doing this. Here's a double and here's a double.
So 2 on the outside, 2 on the inside. 2 to the 4th on the outside.
This is going to come out as a single, and that's going to come out as a
So
single.
it'd be like 2 times 2.
Yes.
And then square root 2.
Yes, and that 2 times 2 becomes
4.
4. Now, if you were to do this one the other way, this is 16 times 2, and that's a perfect square root of 4. Okay, but this one, it is a lot faster, but if you can't think of the 16, you don't even know where to start. And so this way you can start without. Okay. All right, we're done. That was fast.
Yeah.